find the ones that are... Oh, okay. It's number 8. A, B, C, D. Number 8. Wait, A, B, C, D. Yeah, A, D, and A. Yeah, I think just A, D.
Wait,
Because
which problem? Number 1?
Number 8, D.
Oh, 8. Is that the adult height and shoulder problem?
Yeah.
Okay.
I don't know why. I think I just probably made a dumb mistake or something on this one.
All right, this one right here?
Yeah.
Okay, good. Do you know the z-score formula?
It's X minus... Wait, no.
Okay, X minus the mean divided by the standard deviation. Okay? All right. And I'll show you how to use the chart. Do you know how to use the chart?
I understand how to use the standard deviation, but not really.
Okay. So when you look at the chart, the numbers in here is the percentage of the area covered by this graph. Okay?
Okay.
So what they're saying is something like this. Everything in here is 100%. Okay, it's like 100% of the class. And let's say that, okay, so this right here, this is z equals 0, and this is z equals -1, okay? And let's say that this is 1 standard deviation, 2 standard deviations away, and you want to know, like, if you got a z-score of like -1 point, wait, no, sorry, like -0.95, right? Like 0.95 is right here. Like the question would be this: how much area does this cover from left to what?
From left to right.
So you look at 0.95. Now it's negative because it's to the left of the 0. You go to 0.95. So this is -0.9. And the 95 is this number right here. It says 0.95, 91, 92, 93, 94, 95.
Yeah.
So 0.95 will be, let me highlight this. I can't see it. So 0.5, 0.9. Okay, so here's 0.9, 0.95. And then if you go all the way down like this, right? It collides at 0.1711.
Yeah.
Okay, so what does that mean? 0.711 from left to right. So this would be 0.711. Wait, was it? 0.17. Yeah. So 0.1711. So that's 17.11 what? Percent. So the area that it covers is from left to right 17.11% of the graph. Okay. Then what about the rest on the right side? To get the other side, you just subtract this from 100% or by 1. So if you go 1 minus 0.1711, you'll get the area of this side.
Okay.
Yeah, because everything adds up to 1 basically.
Yeah.
Okay. So your z-scores is the stuff on the bottom, and the numbers inside this here is the percent of area that it covers from left to what?
Left to right.
Left to right. Okay.
Okay.
All right. So going back to this problem, now they gave you most of the details here. So you got male, female, height, and shoulder width. So the question is this: how tall is a male if his z-score is 1.6? Now here, I'm gonna try to do it slowly so that you'll really understand what's going on. So
I understand this part. I'm sorry.
Yeah.
I understand how to use the formula for these ones, but I was just confused on the part D. It says it's like the what percent of women are taller than 66.1. I don't know what. Oh wait, is it just?
Okay, so if they're 66.1 inches tall, right? We have to figure out how many percent of the women are up to 66.1. So here, again, this is what I was trying to show you in the beginning. So all of these, you have to always relate it to a normal curve. So for women, their mean is what? 17.7. So
Yeah.
no, I'm sorry, that's shoulder width. Mean 63.6%.
Oh yeah.
Is height. The standard deviation is 2.5, right? Okay. So now where's 66.1? 66.1 will be somewhere over here. 66.1. So the mean, this is z equals 0. Is that?
Oh, okay.
And if you're 63.6 inches tall, you are 50% of the, you're basically with the 50% of all the people in the world of women. But what if you're 66.1? You're taller, right?
Yeah.
So we want to find the average, the percentage of area covered from left to right, and then figure out this. What percentage of people are bigger than what?
Then 66.1.
Yeah, so we're ultimately looking for this area, but the z-score only gives us the area from left to right. So we want to know the z-score for 66.1. How do we do that? Plug it in. So z-score is what? The data minus the mean. So 66.1 minus 63.6. And then you divide it by the standard deviation for women, which is 2.5, right? Okay, so we got 66.1 minus 63.6 divided by 2.5, and wait, what?
I got 1.
You got 1, right?
Yeah.
Okay, you know what that means? It's literally 1 standard deviation away. So it's yeah. So you just go to the chart and look at 1. Go to 1, which is 1.0, which in this case will be 0.84. Can you see that? 0.8413. So 0.8413. So right here would be, okay, so from here to here, well, 0.8413 will cover all of that. That's 81% of the whole graph. So subtract it from 1 and you'll get the upper half. So 1 minus 0.8143. So it's 0.1857. So that's 18.57%. So read the question again. What percent of the women are taller? How much percent of the women are taller? It's 0.1857%, or 18.57% of the women are going to be bigger than 66.1%.
Okay.
Okay. Does that make sense?
Yeah.
Yeah.
I don't know why I wrote down on my paper that it was 16, so I don't know if I looked at. Yeah, it says number 8 is, or 8D is equal to 16%, but I was kind of confused why.
Wait, the answer key says 16%?
Yeah.
Did I do my math wrong? See, 66, we're doing women, right?
Yeah.
66.1 minus 63.6. Yeah, 22.5, and then divided by 2.5. It's 1. I think the answer key is wrong.
That's what I was thinking, because I don't know. I tried doing it several different ways.
Okay, so you did get this number then. That's what you're saying?
I did, yeah, I did get that number, but for since the answer keeps 16%, I was confused on why I couldn't figure it out, if that makes sense.
Yeah, so Z is 1, definitely.
Okay.
Yeah, this is right. I don't think that there was a couple of the problems. There was a couple of problems on this worksheet that I know definitely is wrong. So I forget which ones.
Oh, so maybe it's one of these.
But this is how you do it basically.
Okay. Thank you.
Okay, what else?
I think that was it. It was just the answer key, and then maybe 9F. I just wanted to double check that I did it correctly.
9F?
9C, yeah, 9C and 9F.
Oh yeah, okay. Okay. 9, this one right here, right? Okay, so when you have these like, what do you call it? Less than and with the z in the middle, they're basically asking for something like this. So it's like between here to, let's say here, they want this part right over here. Okay?
Yeah.
Now remember, when you do z-scores or z percentages, it's always from left to what? Left to right. So when you get this, I'll just put z1. When you get this guy, you're going to be given just this part right over what? There.
Left.
So it'll be like this. So that's z1. z2, the one on the right, it's going to include from the beginning all the way up to what?
To the
Here.
end.
So this will be like that. So this is z2. So what you have to do is subtract this amount from what?
From
that.
the second.
So if you cut away this amount, which is up to like right here, you're going to get the leftover, which is just, you know, this part right here.
Okay.
So here, so let's do letter, we'll do letter F first. Okay, so on your chart, the z-score is negative 0.29. So let's go to negative 0.29. Negative 0.29. If you go to negative 0.29, we're all the way over here. 0.3859, right?
Yes.
Okay, so this would be 0.385. Keep forgetting. 3859. 0.3859. Okay. And then the z-score for 3.14 is, I'm sorry, the percentage. 3.14 is 3.1, 0, 1, 2, 3, 4. I believe it's this one, right? Yeah. So 0.9992, got it? So
Yeah.
0.9992. So I'm going to subtract 0.9992 minus 0.3859, and that'll give me the percentage in between. So 0.9992 minus 0.3859. Oops. What did I just do here? Equals 0.6133. So 0.6133. So now if I graph this, 0.29 will be right about here. This. And 3.14 will be somewhere, 1, 2, 3, somewhere here, 3.14. And I want the area right about what?
In the middle.
Yeah.
Yeah.
So I'm going to take everything here, which is 0.9992, subtract this portion, which is only what? 0.3859. And yeah, it's kind of like saying 99% subtracted from 39%.
Okay.
And then whatever's left here is the 61.3%.
Does it also work if you just do it like z is less than 3.14 and then you draw that and then the z is greater than negative 0.29 and then you just shade in like the area in between? Because I think
wait, do you mean this? That's what I did here.
Oh, okay. So I don't need. Do I need to use like the chart for this part? Or
yes.
No?
Z-score doesn't give you percent. The z itself is not a percentage.
Okay.
So when they say p, they mean probability. The probability that you're going to land between a z-score of negative 0.29 to 3.4. So when they ask you for probability, they're asking you for the percentage. All of these numbers are what? The p's. Yeah, probabilities. Mm-hmm. So you have to present these numbers, not... Wait, you're asking, can I just subtract 3.14 minus 0.29, right?
I didn't subtract it. All I did was like, I don't know if I did this. Sorry, it's a little hard to explain, but what I was doing is I took like the p, sorry, not the p. I did like z is, I don't know how to explain it, but I almost did it like if it was like a line kind of, and I like, if z is less than 3.14, I did like a mark on 3.14, and then like...
Which is right here, right?
Yeah. I don't know what I did, honestly. Oh, okay. I did like barriers. So like I did negative 0.29 and then 0.314. And since 3.1, or since z is less than 3.14, I would shade in like to the left. But since z is greater than negative 0.29, I would shade towards the right. And then it like fills in the same area. Does
That's
that also
this.
work?
Yeah, that's so.
Okay.
Yeah, the shading part you would just use this.
Yeah.
So, but the actual answer you have to use the z chart.
Oh, okay, that makes more sense.
Okay. Yeah, you can't get this without the chart. That's the point.
Yeah.
Shading. Okay, if you have to shade it, you can just use this one. So yeah, so 3.14 means 3 standard deviations away and an extra of 14, right?
Yeah.
Yeah. So each little tick mark is the standard deviation. Okay. So yeah, shading wise, you're doing fine, but to get the actual answer, yeah, you have to use the chart.
Okay.
Do you have an answer for C?
I can do it really quick.
You want to just do real quick? Yeah, just to double check. 2.95, negative 2.95. (0.0016) negative 1.12.
I got 0.1298.
Yeah, 0.1298. Very good. Okay. Okay, so that's it for that one. Anything else on this page?
I don't think so. I think just for the review, maybe like problems that are similar to the last unit, or not the last unit, the last like lesson, because I think that's the one that I need the most help on.
Do you remember? Okay, I'm gonna go backwards, but do you remember this one? Okay. Do you remember how to find the coefficient or to expand? Do you remember the procedure? Pascal's triangle.
Is this one? Oh, this was something that was a while ago. It's like when you have to do the triangle you said, right? And then it's, yeah, I need to review that. It made sense when I like did it, but now looking back at it, I would probably need to review that.
Okay, let's do this one real fast because you don't. This one you want to get it right. Like this, if you
Yeah.
get this one wrong, it's like you lost really easy points. Okay, it's just groundwork. You just have to write it all out. But you want to start with the Pascal triangle. Okay, so this one says 5, so we're going to build like 6 rows. So okay, so it'll be 1 2 1 1 3 3 1. Okay, do you remember how to do this?
Yeah, you add like the
4 6 4 1. Yeah, you just add the 2 and put the sum of it below middle, I guess. 1 5 10 10 5 1. So excluding the top portion, n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So if you have something to the 5th power, you're going to use this rule right here.
Oh, okay.
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 All right, and then these numbers are your coefficients for your binomial expansion. You know what binomial means, right?
Yeah.
2 numbers expanded to that exponent. Okay, so what you want to do is, okay, right now for this question, they're saying, what's the coefficient with the term that has an x squared? Okay. So you don't, for this one, you do not necessarily have to expand everything. But I'm going to do enough just so that you can get a hang of the hang of it. Okay, so write 1 5 10 10 5 1 like this, like straight down 1 5 10 10 5 1. Okay, these are your coefficients. And the procedure is really simple. Take the first term, which is 4x, put it in a parenthesis, that all the way down. And then for their exponents, you start with the highest exponent, which is 5, and you work your way down to 0. 5 4 3 2 1 what?
0.
0. And then you take the second term, which is 3y, put that in a parenthesis, and you're going to start at 0 and work your way up. 0, 3y1, 3y2, 3y3, 3y4, 3y5. Okay. Now, since it's a plus, everything is positive. But if you have a negative right here, it's going to alternate positive, negative, positive, negative, positive, negative. Okay. Now, for the full expansion, yeah, you have to multiply everything out. But since we only need something with an x squared, which part of this has an x squared? You see it?
The middle two? Oh, no, not the middle two, sorry.
Yeah, just that one right here, right?
Yeah.
Yeah. So all we need to do is just simplify this out, and we're done. So this is 10, 4x to the squared, 3y to the third, and that becomes 10, 16x squared, and that's 27y to the third power. And then you have to multiply the 10, 16, and 27, which is what? 10 times 16 times 27, 4,320 x squared y what? Cube. So this right here is my final answer. That's my coefficient of the term with an x squared.
Okay.
Okay, so I was telling Adeline, when you start the test, on the back of the test, immediately draw a Pascal triangle, maybe up to like 5.
Okay.
Yeah, and then you can just refer to it. This one, and you also want to memorize this thing, the percentages in here. Do you remember this?
Oh, yeah. It's 34, 34, and then I forgot the rest, honestly.
Okay, so let's break it down, because you don't want to memorize the generic one because it's going to take too much time. And then I'll show you what I mean by this. Hold on. Okay, so this is the one you've probably seen in class. Okay, so this is the one you've probably seen in class right here, right?
Yeah.
Okay. Useless, meaning like if you memorize this during class, you're gonna have to do more like stuff. So it's better to just list it out like this.
Okay.
So memorize this. This will be way faster. So I'll copy this down. This is 0.15, 2.35, 13.5, 34, 34. 13.5, 2.35. Yeah, you basically just have to memorize one side and just reduplicate it on the other. The reason for this is because if they ask you what percentage is between -2 and -1, you could just say 13.5 what? Percent. That you don't have to do like, you see what I'm saying? Like, how do you find this part right here? You have to do like that minus that divided by what? 2? So it'll be easier just to use, this. This one, and then the last one is the z, the x minus the mean, divided by the standard, what do you call it, the z-score formula. I don't think you need to memorize the standard deviation formula because you're going to be using a calculator. Okay, so, all right, so basically 27 to 32, we reviewed it, right? Okay, you need to practice that.
Yeah.
You need to ask your teacher about this. I tried this one, I can't do it. I don't know. Like this, I have no idea. So if you find this one, let me know. Okay. But the rest are pretty easy. Like try this one, number 22. A committee is to consist of 5 members. Do you remember this one?
There's something like the PCB and then the something else. What was it? PCB? Oh.
FCP.
Or FCP. I don't remember. I remember like the process, I think, but it feels so long ago for some reason.
Okay, so FCP, the fundamental counting principle. What exactly is that? Do you remember the example about shirts and like jeans? Like if you have 3 shirts and 2 jeans, how many outfits can you make total?
6.
Yeah, so you just multiply. So anytime you want to find how many ways something can happen, just find the options of each one and just multiply it, okay? And do you remember when we use NCR versus NPR? So permutation deals with order. When something is in particular order, ranking, like first, second, third, or distinction, like like you are separate from this person. NCRs, when you like kind of group things together, like let's say that in your cheerleading team, they're gonna choose 5 players to go to the nationals, right? But it doesn't matter if you're like the top of the 5 or the bottom of the 5. As long as you're one of the 5, you get to go. That's the grouping here. You just kind of group them, and it doesn't matter who's first, second, or what, or third. Yeah. Okay. I don't think you need to memorize the formula, but as long as you know how to use a calculator, you know how to punch this into a calculator, right?
Yeah.
Okay, so now this one's a little bit tricky. It combines several things. Oh, 2 things actually. Okay. So first, read the question and tell me if it makes sense.
A committee is to consist of 5 members. If there are 7 men and 5 women available to serve on the committee, what is the probability that the committee has 3 men and 2 women?
Okay, how many total people are there?
Is it saying that there's 11 people, but then you can only have 5?
Okay, now there are 7 men, 5 women, so there's a total of what?
Oh, 12 people.
12, yeah. And they want to choose how many?
5 people?
They want to choose 5, okay? So now the thing is, they have a condition about these 5 people. What is that? They want the probability that it's made up of 3 men and 2 what?
2 women.
2 women, okay? Now, anytime you see the word probability, you have to use a fraction.
Okay.
And always go for the bottom one first. The bottom one is the total number of ways something is going to happen, right? So what would you put down here? The total number of ways of what?
The total number of like possibilities? Or total of people?
Of choosing how many? 5. Do you get it?
Oh.
So there's 12 people, and the total number of ways of choosing any 5. Any 5. Now the numerator is choosing a particular kind, right? Like the one we want, 3 men, 2 women. But the bottom one is always like just everything. So there's 12 people choosing any 5. There's no like order. There's just like all committee members. So it'll be 12 choose 5 on the denominator.
Okay.
Yeah, this one's tricky. Okay. Now on the numerator, you're going to have 2 things here. Men and what?
Men and women.
Yeah, men and women. You want 3 men and 2 women. That's basically saying how many ways can that happen? Or that's basically using the FCP, fundamental counting what? Principle. Like choosing, like, let's say you have 3 jeans and 2 t-shirts. How many different ways can that happen? So how many ways can we choose men out of all the other men? How many men are there?
There's 7 men.
And we want to choose how many?
Only 3. So would it be
7 choose what?
7 choose 3.
Yeah, is that?
Okay.
So that's like the number of ways you can have like shirts or jeans. But what about women? Well, there are 5 women. You want to choose 2, so it's 5 choose what?
2.
So see, this one is a very complicated one. You have to build it up from ground up. Okay. So yeah, and then you just type into your calculator and you'll get your answer. Okay.
Okay.
And then let's see. Let's skip down to let's try number 4. Okay, do you know how to draw a box and whisker plot, right?
Yes, but I think I need a little bit more practice.
Yes, but. So the answer is no, please tell me again. Which I'll happily do. Just tell me. You don't. Okay. I don't know. Every student's like, I do know, but can you just go over like everything again? Yes. All right. So we'll do the box and whisker plot after this. Okay. An honors algebra 2 student. Okay. Can you read it out loud?
An honors algebra 2 trig student who works for a veterinary clinic part-time is given permission to examine the files of 11 randomly selected adult cat patients and record their weights in pounds. She recorded. And
Yeah. Okay. So she recorded all those. Those are weights of cats, right?
Mm-hmm.
Okay. So now read the first prompt and tell me if you know what they're asking you to do.
Assuming a normal model is reasonable, about what fraction of the cats at this clinic would we expect to weigh over 15 pounds?
Do you get what they're saying?
It's saying like which percentage would be over 15 pounds?
Yeah, how much would be over 15 pounds?
Mm-hmm.
Z-score, Z-chart.
Wait.
Remember, first of all, she's saying assume that a normal model is reasonable, right? So what they're saying is think of this as like a normal curve, okay? And once we find a mean, we have to figure out if 15 is past the mean or below the what?
Oh, below the mean.
Yeah, so let's just imagine it's below. We'll figure it out in a bit. Let's imagine that 15 happens to be below the mean. When now we have to find the z-score, because where it's on the graph, look at the chart, and we'll figure out how many percentage of cats are 15 pounds and below. Mm-hmm. Once we figure out this percentage, we subtract it from 1 to get the other what?
The other side?
That's all the cats that weigh over what?
Over 15
Yeah,
pounds.
they're obese. They're obese feline. They need to go on a diet. Okay? Nobody talks about body shaming cat fatness, right? Okay, so how do we do this? What do we need now? If we're going to find z-score, what do we need? There's 2 things we need. What are those 2 things?
The formula and the chart?
Another 2 things. The average and the standard deviation. To plug it into the formula and the what? And the chart. Okay, so we want to find the mean and the standard what?
Deviation.
Okay, how do we do that? Okay, can you plug all of the numbers into your calculator?
Yes.
Okay, let's do it. Okay. So we got 8.5, 9.1, 9.2, 10.2, 10.5, 11.1, 11.9, 12.6, 13.6, 14.3. Okay, and then just go back and double check everything. 13.6, 12.6, 11.9, 11.1, 10.5, 10.2, 9.2, 9.1, 8.5. Okay. Boom. All right. What'd you get for your mean?
Wait, I accidentally deleted. I cleared it. Is it 10.336?
I got 11.1. Can you double check that?
I'm gonna have to plug it back in because I cleared it on accident. I got 11.17. Yeah, I think I did forget to plug something in the first one.
Okay, let me double check my numbers because you should have gotten exactly 11.1.
Oh.
So 8.1 is 11.5.
Oh, I see what I did.
9.2, 10.2, 10.5, 11.1, 11.9, 12.6, 13.6. Yeah, I got. So I double checked. You should be getting 11.1.
Oh, I did 1.1. I think. Wait, what did I do?
Yeah, just take your time. Make sure the numbers are right. You have like a little like a table, right? That you can look at the numbers.
I was adding it all up and then
Oh, and then dividing by 1, 2, 3, 4.
Yeah.
Wait, do you remember how to just input it into your calculator?
let me try doing it. It's the
You have to start with stats or something.
second data variable 1, and you plug in all the numbers.
Yeah.
5. Oops, I keep doing that. I got is it median? Or mean?
Mean. It should maybe have like an X bar.
Oh yeah, 11.17. That's what I got again.
Oh,
I
wait.
got 11.1 is the mean on my calculator.
Can you tell me what you get for your capital X, the sample?
1.884.
884. Wow. Okay, it's slightly different. It should be the same. Okay, anyways, let's just work with these numbers for right now. And now you can always just double check later.
Yeah.
Okay, so now read the question carefully. Assuming a normal model is reasonable, about what fraction of the cats at this clinic would we expect to be over 15 pounds? Now, the mean is 11.1, so 15 pounds is right about here, right?
Yes.
Okay, so if this is 15 pounds, we need a z-score associated with 15 what? 15 pounds. So how do we do the z-score? Z equals 15 minus 11.1 divided by, now which one number should I use? The capital S or the lowercase s? Do you remember what's the difference?
No.
The capital S is a sample.
Oh, okay.
Lowercase s is the population, like everything. So if you look at the prompt, it says that he randomly selected 11 out of everybody, right? So it's a sample, so we have to use 1.97. You see it?
Yes.
So this will be 1.97. Okay, let's calculate this. What do you get? 15 minus 11.1 divided by 1.97. I got 1.98. Get that?
I got 2.03. Let me do it one more time.
Oh man, what's going on with our answers here? 15 minus 11.1, 3.9 divided by 1.97.
0.97.
Yeah, 1.979, so 1.98, right?
Okay.
Okay, now we go to the Z chart and go to 1.998. So 1.98. 8 is that one. So this one right here. 0.9761. Do you get that?
1.98. Yes.
Yeah. 0.9761. So 0.9761 will represent this. 0.9761, like everything up to here. See it? So what it's saying is 97%. Well, it's not 97% of the class. I mean the class or the cats. He's at the top 97. So if you subtract it from 1 minus 0.9761, so this would be 0.0239, so 2.4%. So 2.4% of the cats will be bigger than what?
15% or 15 pounds.
15 pounds. Okay, so 15 pounds is a lot for a cat.
Mm-hmm.
Okay, so answer right here will be 2.4% or 0.00231. Okay, now read the second one. According to the what?
According to the empirical rule, about 95% of the cats at this clinic should have weights within what range?
Do you understand that?
Is it asking like for the mean?
No. So whenever they say empirical rule, they're referring back to this chart. Where's that chart? This thing?
Mm-hmm.
So 95% is 2 standard deviations away. Do you see this?
Yes.
Yeah. So what they're saying is, if this is 95% of the cats, then from -2 to +2, what's the actual weight of the cats? So if you're at -2 standard deviation, what's his weight? So we'll go from -2 to 2. So they want to know -2 to +2, right?
0.95. 22?
No. So we want the actual weight. So watch this. So this is a z-score. So we go like that. Z equals x minus the mean divided by the standard deviation. We're looking for this right over here.
Mm-hmm.
So z is, for the left side, will be -2 equals x minus, and what's the mean again? 11.1 divided by 1.97. So that's for -2. And let me do one for +2. So 2 equals x minus 11.1 over 1.9 what? Yeah. So meaning we want the actual weight when he's 2 standard deviations away from the left side and the what? The right side. So this is 95% of all cats weigh between this weight to that weight. So, okay, now it's just algebra. Multiply both sides by 1.97 and then add 11.1. So -2 times 1.97. And then that's -3.94. And then we add 11.1 to both sides. So plus 11.1. So cats 2 standard deviation to the left are 7.16 pounds. Okay, so I'll put right here 7.16 pounds. And then the right side will be, let's see, 2 times 1.97 and then plus 11.1. So 15.04 pounds. So this would be, okay, let me just stop here and ask, is this making sense?
It's making more sense, but I'm definitely going to have to practice it on my own.
Okay, so now do you see what's going on? We're using this equation, you know, the z equation?
Yes.
And there's 2 uses for it. One is actually finding the z-score by plugging in x, mean, and the standard deviation. But in this case, we're using it for a different reason. We're given the z-score of -2. We want to find the actual weight. This?
Yeah. Value.
The weight of the cat. Like if his z-score is -2, then what was his original what? His original weight. Now there's 2 ways you can actually do this. We can use the equation. It just happens to be -2, so that's 2 standard deviations away, right? So if the mean, if right down the middle, if the mean is 11.1 pounds, and the standard deviation is 1.97, shouldn't we just subtract 1.97 twice from 11.1? Do you get that idea? If the mean is 11.1, let me write it down here. So if the mean is 11.1, 1 standard deviation away is subtracting that deviation from the mean.
Okay.
So if the deviation is 1.97, right? So take 11.1 and subtract 1.97. And you get 9.13, correct?
Yeah.
That's this one. That's one standard deviation away. 9.13 pounds. And if you subtract the deviation one more time, so do 9.13 minus 1.97, what do you get? 7.16. Okay. Now, the reason I can do it for this one is because it's literally at the second standard deviation. But if it was between, you have to use the Z thing. So to get to 15.4 pounds, what do we do?
You can
start from the mean and add what twice?
1.97 twice.
Yeah, and then you'll end up at 15.04. Okay, does that make sense?
Yeah, that makes more sense.
Okay. All right. Dang, that's just letter B. Okay, so the answer for B would be his weight should be between 7.16 to 15.04. Okay, now try this one then. Letter C.
Okay. So I would have to start for the standard deviation first, right?
Yeah, we have all of our information. So if the cat weighs 27.2, no, I'm sorry, the cat's z-score is 2.72. So he's 2 standard deviations away with an extra 0.72. So how much does the cat weigh? So if he's at 2.72, what's his actual weight? So what should we do?
You have to find the standard first, the standard deviation first.
Oh, wait, we have all the information. Standard deviation is 1.97. Oh, it's the same problem. And the mean is 11.1. We want to know how much the cat weighs if he's at 2.97. Okay, let me clarify. Whenever it says z-score, it's asking where on this graph are you at on the bottom right here. Where are you? If you're 0, you're right in the middle. 2.72 means you're 2 standard deviations to the right.
2.72. Okay, so 2 standard deviations.
So is this cat gonna weigh more than 11.1 or less?
It'd be less than 11.1?
No, think. So here. So okay.
Past the mean?
Right. So okay, so again, I really once this clears up, it should be easy, okay? So the mean right now is 11.1. See this?
11.1.
Yeah. And one standard deviation away is going to be bigger than 11.1.
11.1 plus
yeah.
the 1.
So here, let me try this. I'll put 0, 1, and 2, -1 and -2. These numbers are my z-scores, okay?
Okay.
Underneath the z-score, I'm going to put the weight. So if you're right at the middle, you're 11 point what? 1. Yeah, let me draw it in like different color. So the numbers 0, 1, 2, 0, -1, 2, these are your z numbers, okay? These are like z, okay? The actual weight, I'm going to put it right underneath. So if your z-score is 0, you are at 11.1.
Okay.
And then if you move to the right, you have to add the standard deviation, right? Which is 1.97. So if I add 1.97 to the mean, 11.1 plus 1.97, this is at 13.07, and then plus 1.97. So 15.04. Okay, so the mean is 11.1. I don't know why that looks so big. Pounds. If you're 1 standard deviation away, you would weigh 13.07 as a cat. If your z-score is 2, you will weigh 15.04 what? Pounds. Now, what's the z-score we're looking at? His z-score is 2.72, right? So that means he's going to be, if this is 3, 2.72 will be right about what?
Like in between the...
Yeah. So will it be bigger than 1504 or less than 1504?
Bigger than 1504?
Yeah. So if his z-score is exactly 2, he would weigh 15.04 pounds.
Mm-hmm.
But we want to know what 2.72 is. Now, do you know what 3 would be if his z-score was 3?
It's 15.04 plus the standard deviation.
Yeah, 1.97, right?
So 17.10.
Yes, that is a huge cat. 17.01 pounds. But when you do one standard deviations at a time, it's easy to figure out what the weight is. But what would happen if your z-score is between 2 and what? 3, like right here, 2.72? That's why we need to use the z formula. So the z says that z equals x minus the mean. So we have our z, which is 2.72, so we just plug it in. You see that? We have the mean, which is 11.1. We have our standard deviation is 1.97. So guess what? All we need to do now is solve for his weight. Does that make sense?
Yeah, that makes more sense.
Now it's just algebra. Okay, is that really making sense? Like, see how this works?
Yeah, it really is. Mm-hmm.
I'm guessing your confusion was you kept getting mixed up with z-score and the like actual weight, right?
Mm-hmm.
So okay, so this setup makes. Sorry?
Oh, sorry. Yeah, I was thinking that it was saying that it was the weight, not the actual z-score for some reason.
Yeah.
And then I was just like confused on when to apply the formula or when to search like for this.
Right. Exactly. So most students get confused because they put the same z-score on the bottom and they end up putting the actual data on the what?
On the bottom too.
Yeah, it's like they represent the same thing, okay?
Yeah.
So yeah, z0 means it's the mean, so 11.1. One standard deviation is just, so on and so forth. So the formula in the chart helps us with everything in between these numbers. Okay, so how much does this guy weigh? So 2.72 times 1.97, and then you add 11.1, and this cat is a whopping 16.46 pounds. Wow. Now, I don't have cats, but I think it's a lot.
Yeah.
My dog's been getting fat, so I've been withholding some food for her. Okay. Okay, so if you have to just review this segment on the video, as long as this makes sense, like what does the z represent and how does it relate to the actual weight of things or the data, you should be able to work with any questions that they throw out at you.
Okay.
Again, anytime they say the word empirical rule, they're saying use the chart. I mean, use the graph, the breakdown. This thing.
Mm-hmm.
Yeah, this thing right here. This one and also what? So you should definitely memorize both.
Both of them. Okay.
Yeah, 68% is the middle right here. 95% is two standard deviations away. Yeah. 68 is 1, and then three standard deviation away is 99.7. Okay, all right, we got 5 minutes. Let's try to do one more. Okay, so let's work on the box plot. So let's go to number 1.
Okay.
Okay. So, first thing you want to do is write these numbers in numerical order from least to greatest. So, I think 8 is the smallest. Yeah. So 8. And then 950, 9.5, and then 10, right? Or 10. Yeah, 10.
10.25.
There's 2 10s. And then 3 10.25. So 10.25, 10.25, 10.25. So 1, 2, 3. And then 11 and 11.25, and then 12.75. Now, Just make sure you got all of them. So there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is obviously the hardest part to this, right? Putting in numerical order without messing up. What you want to do is cut this in half, cut the data in half. So there's 10. If you divide it by 2, you're going to get 5. So group them into 5. 1, 2, 3, 4, 5. And then the second group also has 5. Now, use these little buckets. It's the best way. I know some teachers do this slashing thingy. Hate that. So group into buckets. And the median is right in the middle between these two. So if the numbers are the same, it's going to be the same thing, 10.25. But if the number are different, if the two numbers are different, then add it up and divide it by 2 and find the average between those two. Does that make sense? Like if this was like 9 and 17,
add them and
divide by 2, you'll get the middle number. Okay, so that's your median. So let's write this down. This is median. And then the first quartile is just the half of the first group. Now the first group has 5 numbers, so it'll just be 2, 2 on each side, right? Like that. And so the middle guy happens to be the first quartile. And do the same thing for the second group. See how easy that was?
Yeah.
There's 5 numbers, so obviously the third one, the middle guy right here, that's your third what?
Third quartile?
Yeah, third quartile. Now the number in the way in the bottom, that's your can't think of the word. Least? No, minimum. Minimum. And the biggest number at the right is your maximum. And you just need these 5 statistics to draw a box plot. Okay, so draw this number like a ruler number line out. The smallest number is 8, so start there. The biggest number is 12.75, so let's go all the way to 13. So 8, 9, 10, 11, 12, 13, and just plot these 5. So minimum is 8.95, so we're going to put that. No, I'm sorry, 8. It's just 8. And the first quartile is 10. So here, the median is 10.25, which is like somewhere there. Third quartile is 11, so put a dot there. And the max is 12.75, so right over there. And put the box enclosing the first 3 dots. I mean the middle 3 dots, like this. That.
Okay.
And then draw your whiskers to the max and the min. And there you go. This is your box and whisker plot.
Oh, okay. I do remember.
Now, each segment has 25% of the data. So this is like 25%, 25%, 25%, 25% of the data. The median is the middle. Okay, the distance between the first quartile, the length of the box, is called interquartile range, IQR.
Okay.
So she might ask for that. You just subtract 11 minus 10, which happens to be 1. So
10.
Okay.
Okay.
Okay, and then just try to answer the rest based on the other stuff that we learned.
Okay.
All right. So study hard, and then text me questions if you have any questions.
Okay. Thank you.
Have a good night.
Thank you, you too.
Recording stopped.